Hi, student. I'm going to give a lecture on the first topic for CHE246 separation process. Okay, so this is the first chapter. So altogether, you have 5 chapters. Okay, let's proceed with the first chapter. Okay, let me share with you the slides that we have. Okay. Okay, so the first chapter, mass transfer. So what do we have to know about mass transfer? Okay, so when we talk about mass transfer, we can talk about how the particles move from one place to another place. Okay, so we have here a very simple definition on mass transfer. So we are talking about species or matter that will slowly move from one places to another places due to the concentration gradient. So how that particle move? It move from higher concentration to lower concentration. So this is called the high concentration to lower concentration is called concentration gradient. So it's easy for you to say that what is mass transfer? Mass transfer is when species or matter move from one place to another place due to the concentration gradient. And the mass transfer move from higher concentration to lower concentration. So this statement shows you the direction of the mass transfer, how the mass is transferred from one place to another place. Okay, so we have one example here. If you look at this picture, so evaporation also called a process of mass transfer. So you can see the small particles move through the air based on the mass transfer concept. Okay, so you can have here, down here, you have high concentration of water molecules. Then when mass transfer takes place, it transfer from this bulk of concentration of water to the environment. So in the environment, you have lower concentration of water molecules. So the transfer is from the water to the environment. Okay. And then another example that I can explain to you is about when you have sugar in the water, in a cup of water. Okay, so maybe when you put the sugar in the cup and you pour water, you still can see the sediments of sugar at the bottom part of the cup. But after a few minutes or maybe few hours, you can see that you can have a sugar solution. So why does it happen? It happened due to the higher concentration of sugar at the bottom of the cup, and it's moved to the water because you have lower concentration of sugar in the water. Okay, so this is how you can describe and give some examples regarding to the mass transfer. Okay. All right, the next one is about the diffusion, which is related to the mass transfer. So we're going to make the scope smaller. So we're going to talk about diffusion. Okay, how diffusion occur. All right, so we have a situation where you have only one types of particles, one species only. Okay, so let's say you have that particular molecules in one side of the container. All right, so the other side of the container, let's say you call this orange color particle as particle A or species A. All right, so at this place, okay, this place, you have higher concentration of particles A, but on the right side, you have lower concentration of particle A. Therefore, particle A will diffuse into the water due to the concentration gradient. Okay, so it will occur, okay, it will continuously occur. Okay, you can see the transfer of the particles from left to the right, and then you have also right to the left. Okay, it's occur this way, all right, until it reach equilibrium. So what does it mean by equilibrium? Equilibrium represent the concentration gradient on the left side of the container equal to the concentration of particle A on the right side of the container. But the transfer is still occurred. It's still occurred. Okay, so this is called the equilibrium situation. Okay, and then if you were to have two particles, all right, two particles, so you can see that you have orange particles and purple particles, all right. Let's say purple particles, you have about 6 particles, and then you have orange particles, all right. So diffusion will occur for orange particles where it moves from left to right because you have higher concentration of orange particle on the left side compared to the right side. So same thing happened to the purple particles, okay? So you have high concentration of purple on the right side compared to the concentration of purple particles on the left side. So diffusion will take place, right? So until it reach equilibrium, where you can get the number of particles of orange and purples will be the same on the left side or in the right side of the container. Okay, so when you talk about diffusion, you can talk about one types of particles, or you can describe more than maybe more than one particles. Okay, so that is how you describe the diffusion process. Okay, all right, so this is the last part for this lecture. So we're going to look at the Fick's law for molecular diffusion. So we're going to use Fick's law. Okay, so this is general equation of the Fick's law, right? So you have Ja represent the molar flux, okay, of component A, and then you have C is the total concentration. So if you talk about two particles, so you have the total of concentration A plus concentration B, okay? And then you have concentration A, which is your Ca, and then you have Xa to represent the mole fraction. So if you have subscript A, means that you have mole fraction for component A, okay? And then this is another constant particles, which is called diffusivity of the molecules A in B. So if you were to have diffusivity of B in A, the symbol would be dBA, okay? But the value for this diffusivity will be the same for DAB, which is also equal to dBA, okay? And then Z represent the distance of diffusion, all right? So since we are talking about distance of diffusion, and we have discussed about the direction of diffusion, which is the movement from higher concentration to lower concentration. So therefore, Z is actually a vector, okay? Z is a vector. So that's why when you talk about the Fick's law, you need to know where is the magnitude, the second position, and you have to know the first position or the second position. So you have to state the position. So the first position represents the initial position, and then the second position represents the final position. Okay, so that will represent later to be the distance of diffusion, meaning that one particles, they move from A to B, for example, from 1 meter to 3 meter. So the total distance would be 3 minus 1, okay, which is 2 meter. Okay, so this is the basic concept of Fick's law. Okay, so the next slide will be the Fick's law for steady state diffusion of a binary mixture. Okay, so this is a very important because you need to differentiate, because you need to differentiate between the transfer of gas, the transfer of the liquid. So most of the cases that we have to talk about in this syllabus is about the transfer of liquid and the transfer of gas molecules. Okay, all right. So as you were introduced before, so this is called the Fick's law. Okay, how you calculate the flux. Okay, how you calculate the flux. All right. So the flux represents the magnitude that you would like to know, whether it is a low flux, or high flux. Okay. So you can also play around with this formula. So I would like you to at least please study first how to get from the first equation until you get to the last equation here. Okay, so think about it first and I'll get back to you and you need to explain. Okay, all right. So I'm stop sharing with you the slides. So it's your turn to figure out first how we can get the formula that I've shown you just now from the first formula until you get the final formula. So that's your work. Okay, so you can begin now because this is your turn. I'll get back to you. Okay, all right. Assalamualaikum.